We have another question here. Question 3. Question 3.1 says the first three terms of an arithmetic sequence are 2p plus 3, p plus 6, and p minus 2. Now, the question says 3.1.1. The question says that show that p equal to 11. Okay, so I'm gonna write the question over here. 3.1.1. Okay, first of all, 3.1. It is said that's 2p plus 3, and then p plus 6, and then p minus 2 are the first three terms of an arithmetic sequence. Okay, the fact that the sequence is arithmetic, okay, we understand that it has a constant difference. So the difference between 2p plus 3 equal and p plus 6 equal to the difference between p plus 6 and p minus 2. So we will do p plus 6, okay, minus 2p plus 3. It is important to put the bracket as I did, okay, and then p minus 2 minus p plus 6. So let's work it out. Let's simplify. If I drop the brackets, this will be like p plus 6 minus 2p minus 3 equal to p minus 2 minus p plus actually minus 6. Okay, at the moment that we drop the bracket, the sign will change. Now p minus 2p, if I look at the like terms, p minus 2p makes negative p, and then p, 6 minus 3 here will make positive 3, and then equal to, and then over here p and negative p will fall, and then that will make negative 8. Now if I move the 3 over, that will be negative p equal to negative 8 minus 3, negative 8 minus 3. So this minus 3 doesn't, okay, minus 3, and then that makes negative p equal to negative 11. So this means p is just equal to 11. Okay, and then the following question is 3.1.2. It says calculate the smallest value of n for which Tn be lesser than negative 55. All right. First of all, we are going to determine T. Okay, I'm gonna write here. That was 3.1.1, and now I'm gonna write over here 3.1.2. So we are looking for the smallest value of n. Okay, such that n is lesser than negative 55. So what am I going to write here? Let's first find Tn. We know because it is an arithmetic sequence, okay, Tn must be equal to a plus n minus 1 times d. D is the constant difference. Now the fact that we already find the value of p, which is 11 here, we can find the exact values of the first three terms. Okay, so the terms here will be 2 times p plus 3, which is 22 plus 3, so it's going to be 25. The terms will be like 25. Okay, and then p plus 6, so 11 plus 6, which is 17. And then p minus 2, so 11 minus 2 is 9. Now we can notice that the constant difference here is of 8. So 8, the constant difference, 8. Therefore, if I can move my board this way, Tn will be written as like a, the first term 25, plus open brackets n minus 1 times the actually negative 8, okay, because decreasing negative 8 times negative 8. 17 minus 25 is negative 8. So Tn will be equal to 25 negative 8n plus 8, because just times negative 8 times n, and then negative 8 times negative 1. And then this will be 25 plus 8 is 33 minus 8n. So I prefer to write negative 8n, negative 8n plus 33. This is Tn. Okay, but now we are looking for the smallest value of n for which Tn will be lesser than negative 55. So what am I going to say? I'm going to write here negative 8n plus 33 lesser than, okay, negative 55. So if I move 33 over, we're like negative 8n will be lesser than negative 55 minus 33. And then this is negative 8n must be lesser than negative 88. So to find n, I must divide here by negative 8 and then negative 8 there. And then this will make n lesser than 11. Actually, careful. When we divide by negative 8, the symbol, the inequality symbol must change, okay? It must reverse because we divide by negative number. So it's going to be greater than 11. So n must be greater than 11. Therefore, n must be like term 12, for instance, okay? N must be greater than 11. So, okay, maybe just do this. Now, the following question is question 3.2. Question 3.2 says, given that the sum of x minus 3k, k starting from 1 to 6, equal to the sum of x minus 3k, k starting from 1 to 9, then prove that the sum of x minus 3k, k starting from 1 to 15 equal to 0. Okay, I'm gonna move my board this way. And then 3.2. So it is said that the sum of x minus 3k equal to, okay, sum of x minus 3k, and then we need to prove that the sum of x minus 3k, okay, here k starting from 1 to 6, and then here k starting from 1 to 9. So we need to prove that the sum here, k starting from 1 to 15 equal to 0. So if this is true, then this part here equal to 0. That's what the question means. We need to prove that this part is equal to 0. Okay, how can we do that? First of all, let's work out, okay, the sigma notation here is just a sum, okay? So we can, and then I can see this is an arithmetic sum because we're a product here 3k, like that. If it has an exponent, then we'll say if the variable was exponent, we say geometric, but because it's a product here, we'll say it's an arithmetic sequence. Now we know that Sn for arithmetic sequence, okay. Sorry about that. I meant this over here, there, and then we know that Sn for arithmetic sequence is given by n over 2, okay, 2a plus n minus 1 times d. So we can work out S. So this implies that S6 will be equal to 6 over 2. Okay, 2a. A is the first term of this sequence, so it means when k equal 1, so if k equal 1, we sub 1, there's going to be x minus 3. So 2, going to be here 2, open brackets, x minus 3, okay, plus n minus 1, 6 minus 1 times d. What is d then? The constant difference. So let me first list a few terms here. If k equal 1, then we have like x minus 3, 1 will be equal to x minus 3. And then if k equal to 2, then it's going to be x minus 3 times 2 here, and then x minus 6. Now let's find the constant difference. It means x minus 6 minus x minus 3. Okay, because this is like term 1 and that term 2. So now take term 2 minus term 1. X minus 6 minus x in the bracket like that, x minus 3. Now this will make x minus 6 minus x plus 3. So and then x and x falls, and then we have left with negative 6 plus 3, which is just equal to 3. This is equal to 3, so times 3. And then this will be 3 times, we can extend this, that makes 2x minus 6 plus 5 times 3 is 15. Okay. And then that will be okay, negative 6 plus 15 is just equal to positive 9. So all this makes 9, and then that makes 6x. 3 times 9 is negative 27. Okay, am I right? Okay. Oh, oops, sorry. This is the negative 3. Sorry, minus 6 plus 3 is negative 3. So over here it's a negative 3. So we have like instead of plus x here, it's not plus x. It's a minus. Okay, because 5 times negative 3 makes negative 15. Yes, that's a negative 15. So negative 15 there, and then negative 6 minus 15 is not equal to 9. This is equal to negative 21. So that makes negative 21. Now 3 times negative 21 is negative 63. Negative 63. So this is equal to, the first part here is negative 6x minus 63. Now S9 will be equal to 9 over 2, open square bracket, 2 times x minus 3, plus 9 minus 1 times negative 3, the constant difference. Okay, and then this will be 9 over 2, open square bracket, 2x minus 6, and then plus that makes 9 minus 1 is 8. 8 times negative 3 makes negative 24. Okay, negative 24, and then this will make 9 over 2 times 2x, negative 6 minus negative 24. So this sum here makes negative 30. So this makes negative 30 here, negative 30. Now we have like another times. If I times 9 over 2 times 2x, this is just 9x. And then 9 over 2 times negative 30, this will be 9 times 15. Okay, let's just use calculator. but I know it's 135, but let's double check. 9 over 2 times negative 30, and then this will be, yes, I was right, negative 135. So now, so it is said that the sum, the two sums are equal, okay, because this is S6 and then that's S9. The two are equal to each other according to question here. So we're gonna do 6x minus 63 equal to 9x minus 135. If I move, I prefer to move the 6x over and then the negative 135 over, and then this will be positive 135 minus 63 equal to 9x minus 6x, and then 135 okay, 135 minus 63 equal to 72, and that's equal to 3x. Now we divide both sides by 3, we'll get x equal to 24. Now that we got the value of x, we can solve and check if this sum will be equal to 0. Now I'm gonna move my board like this, and then split it like here. Now the sum that we have over here, sum from k from 1 to 15, okay? So this sum will be I'm gonna write therefore the sum of x minus 3k equal to 0, k starting from 1 to 15, will then become the sum of x is 24 now, k starting from 1 to 15, and then I will sub 24 instead of x, okay? 24 minus 3k. So because we know the first and last term, we can use this formula. S, you know, n is also equal to n over 2 a plus l. Okay, we can use this formula. So we know that a will be the first term when k is equal to 1. So we sub 1 here for k. So it's going to be 24 times minus 3, which is 21. And then L, the last term, will be when k is 15. So if you sub 15 there, 3 times 15 is 45. So 24 minus 45 equal to negative 21. Okay, so if we check 24 minus 45 equal to negative 21, and then we can just say Sn will be equal to n over 2, so 15 over 2. Actually, it's n 15 now. In case someone didn't understand what I did here, I sub the value of k. When k is 1, you sub 1 there for k. So if you sub 1 for k, you get, let's do it here. So if k is 1, then we'll have 24 minus 3 times 1, which is equal to 21. This is when k is 1, which is the first term. Okay, and then when k is 15, the last term. So if k is 15, the last term, this means 24 minus 3 times 15, and then this is equal to negative 21. Now we do 15 over 2, so 21 21, positive 21 plus minus 21. Of course, 21 minus 21 is 0. Okay, and then you're like S15 will be equal to 15/2 times 0, and then that's equal to 0. Therefore, proven. Thank you.